So this is a video for second derivatives with implicit differentiation, and we're just going to go straight to these two examples. So I'm assuming you know the basics of this. If you don't, and you want like a more basic example just to see the breakdown, highly recommend you check out my lesson video. So these are going to be a little tough, okay? So let's start by taking the first derivative. So we need to get to the second derivative with this. So first I'm going to take 2y dy dx, and so then this is going to be e to the 5x times 5 minus 5. So there I've used the chain rule. I'm setting up my implicit differentiation. At least this one's going to be nice and straightforward to figure out dy dx. So I've got 2y dy dx equals 5e to the 5x minus 5. So now my dy dx is going to equal, oops, I missed that part, 5e to the 5x minus 5 over 2y. Okay, so that's the first part. So now let me get some space so we can start working on the next derivative. Okay, so now I'll write y double prime, and we'll just go ahead and implicitly differentiate this side. So I've got to use the quotient rule here. So first I'll take the derivative of the top. So this will be 5e to the 5x times 5. So I got to use the chain rule there. And then this other 5 will drop out since it's a constant, and I multiply that by 2y. And then I subtract that from 5e to the 5x minus 5. And then I take the derivative of 2y. The derivative of 2y is just 2. And then dy dx, since I took the derivative of y. And then all of this divided by 2y squared. Okay, so now you've got to make some choices about how are you actually going to simplify this. And this does become a little bit of an art form. So I'll kind of walk you through this. So this first part, I'm just going to multiply all of this together. So 5 times 2, so that's going to be 50 e to the 5xy. And now for this part here, so remember with the second derivative, you have to rewrite your dy dx. You're going to have to rewrite this as this. So I actually don't want to distribute the dy dx part. I just want to distribute the 2. So I literally just want to take this 2 and distribute it to these two parts here. So if I do that, and then also don't forget about this minus sign right here. Okay, so this is going to become, I'm going to have to leave parentheses here actually. So this is 10e to the 5x minus 10 times dy dx. And again, the only reason I didn't distribute the dy dx is because I know I have to rewrite this out again in a moment. So I'm just trying to save space here. And then all of this is going to be over 4y squared. Okay, so now the last step of this is once you've kind of evaluated all this, then you have to replace your dy dx when you're working with the second derivative. You have to replace that with your first derivative. So it's kind of like you are using dy dx just to help you kind of think through this, and then you have to actually go back and replace it in the end. So let me clear some space, and now we'll just restate the final answer. So this is 50e to the 5x times y minus 10e to the 5x minus 10, and then 5e to the 5x minus 5 over 2y, all of this over 4y squared. And you could keep kind of simplifying with this if you wanted. I think this kind of gets us to our point. But there's kind of all the work that goes into the second derivative. Okay, so moving on to b here. So now I've got to take the first derivative. So let's see, as I work through this, the 3 will drop out. This minus cosine y will become positive sine y, dy dx. And then this will be 4 plus 2x. Okay, so at least solving for dy dx is not too difficult. So this will be 4 plus 2x over sine y. But now we can see that taking the second derivative is going to be a little work, so let me make some space. Okay, and it's time to get the party on. So y double prime got to use the quotient rule again here, right? So first I take the derivative of the top, which is just 2, and then I multiply that by the bottom, which is sine y. And then I leave the top alone, and I take the derivative of the bottom, which will be cosine y dy dx. And then I square the bottom, so we'll call this sine squared y. And so now from here, we kind of have that same situation from last time, so it's just kind of a game of how far are you going to simplify this. So I'm going to write this out as 2 sine y minus, let's see, I'm going to bring the cosine y out in front. I'll leave the 4 plus 2x here. And now I have to replace my dy dx with the first derivative. So this is going to be, this is going to be 4 plus 2x over sine of y over sine squared y. And then you could actually rewrite the cosine y over sine y. You could write that as a cotangent if you wanted. So you could, once again, you can kind of keep going with this. If that's something that you want to see me actually work out, leave me a comment. I kind of was on the fence if I wanted to do that with this video. I really wanted to just show you how the setup works. But just leave me a comment, and I do read your comments. So if you want to see more, I'll make more. So that'll cover it for this video, guys. I'll talk to you next time. Thanks for watching.